Hello everyone. So today's video is on arithmetic sequences. We're going to begin by just doing an introduction to what a sequence even is, and then we'll get into the basics of arithmetic sequences. Okay, so like I said, tonight we're going to talk about sequences. We're going to start off with just what is a sequence. And it's basically just a set of numbers written in a given order. So anytime you have a special order in which you are organizing numbers, that could be considered a sequence. So I could do as simple as 2, 4, 6, 8, 10. That would be a sequence. Now it is generally defined by an equation. For example, the way we read this is a sub n equals 2n plus 1. So notice how I said that a sub n. If you look at the little n here, it's not an exponent. It's actually a subscript, which means that it's just a little bit below the a on the right-hand side. And so we literally say a sub n equals 2n plus 1. In a sequence, each of the numbers is considered a term. Okay, so each number in the sequence is considered a term. The first three terms of a sequence, we denote them by saying a sub 1, a sub 2, and a sub 3. So the little number that replaces the n, that becomes the term number. Okay, an explicit formula is a formula that allows for the computation for any term. So that's a formula in terms of n, and where I can plug in any number for n and find that term number. A finite sequence is a sequence that contains a countable number of terms, such as -2, 0, 2, 4. This is countable because it ends. In this sequence, there's exactly 4 terms. An infinite sequence is a sequence that continues on forever. And the way you recognize that it continues on forever is, of course, it ends in a dot, dot, dot. So, for example, 0, 1, 2, dot, dot, dot. That indicates that it's going to keep on going forever. Okay, so if you look here at number 1, this is an example of what we called an explicit formula. It is a formula in terms of n. So a sub n is equal to 8n minus 2. I want you to notice the connection that this has to function notation that we just got through doing. Function notation would say f of n is equal to 8n minus 2. Very similar. Okay? The same way that you replace the n in function notation in here, okay? When you replace that, you also replace it here, and then you evaluate your term. It's the exact same thing here. So if I'm asked to evaluate, given the formula a sub n equals 8n minus 2, find the first 4 terms, and you can see they denote them a sub 1, a sub 2, a sub 3, and a sub 4. So we're going to find them one at a time. And just like with function notation, when I write down a sub 1, I have now replaced the n with a 1 in this formula. So everywhere where I see an n, I'm just going to replace it with a 1. So 8 times 1 minus 2, which is 8 minus 2, which is 6. So the first term in this sequence would be 6. A sub 2 would equal 8 times 2 minus 2. So again, where I saw the n in the formula, I replace it with a 2. And so 8 times 2 is 16, minus 2 would be 14. A sub 3 would be 8 times 3 minus 2. So that would be 24 minus 2, which is 22. And lastly, a sub 4 is 8 times 4 minus 2, which would be 30. So there we have it. That's how we go ahead and find the first 4 terms of a sequence. Now, you can leave your answer like that, but I could also group it together. You can see that oftentimes when we name sequences, we see them in these curvy brackets. And so we could list them 6, 14, 22, and 30 would be the first 4 terms of that sequence. Find the 10th term for the sequence a sub n equals -1 to the n over n minus 2. So they're asking specifically for a term. I need to understand then they're asking for the 10th term. So in order to write that, I would say a sub 10 equals, and now wherever I see a n, I replace it with a 10. So I have negative 1 to the 10 over 10 minus 2. And if I have my calculator, I would type that in, of course, using the alpha y equals, just to make sure that I have everything it should. And you would end up with an answer of 1 over 8. And so that is the 10th term of that sequence. Okay, so now let's talk about arithmetic sequences. Arithmetic sequences are a specially defined type of sequence that we study in Algebra 1. An arithmetic sequence is a set of numbers that have a common difference added to each number to get the next term. For example, 2, 5, 8, 11, 14. The common difference would be what? Well, each time, in order to figure this out, I say, what am I adding to 2 to get to 5? And 5 to get to 8, and 8 to get to 11. In other words, what is it going up or down by? And in this case, obviously, it's going up by a positive 3. So my common difference is 3. The graph of an arithmetic sequence is linear. The graph of an arithmetic sequence is linear. In fact, in general, arithmetic sequences are considered linear functions. Okay, to find any term of an arithmetic sequence, we can use this special formula. Now this looks pretty intense, this formula, lots of different letters, lots of symbols. Okay, thankfully, this is given on the formula sheet. So on your exam, you are given a reference sheet, and this is on it. Okay, so we don't have to memorize this formula, which is very exciting, but you do need to be able to remember to go to your reference sheet and take it and know when you're going to use it, and that's what we're going to work on here. Okay, so as I read the formula from left to right, it says a sub n is equal to a sub 1 plus n minus 1 times d. Now, what do all these things mean? Well, a sub n is the nth term of the sequence is equal to the first term, a sub 1 is the first term, plus the number of terms minus 1 times the common difference. So that's the general formula for any arithmetic sequence. We have to be given, in order to work with this formula, in order to write a formula, you have to be given the first term, which of course is a sub 1, and the common difference. Okay? All right, so now let's actually try a few examples. For these first three, all we're doing is finding the common difference for each of these arithmetic sequences and naming the next term. All right, so take a look. 5, 11, 17, 23. What am I doing to get from 5 to 11, 11 to 17, 17 to 23? Well, the way that you can find the common difference, although these ones are very obvious, if you ever get stuck, you can always find the common difference by taking, what am I doing here really? I'm taking the first term and saying how much do I have to add to it to get to the second term? Or in other words, take the second term and subtract away the first term and you would get your common difference. So in this case, 11 minus 5 is 6. Now, like I said, some of them you can just figure that out, but there are times when that formula might be helpful. Okay, looking at the next one. All right, if I look to see what's happening, I go from 20 to 16, 16 to 12, 12 to 8, 8 to 4. This time, if I were to do that same rule and take my second term 16 and subtract away my first term 20, it should not surprise me that my common difference is negative. Why is it negative? Well, look at the pattern. These numbers are going down. So you're adding a negative number every time. Therefore, the values are decreasing. All right, the next one are actually binomials in terms of x. So what am I adding to x minus 1 to get to x plus 4 and x plus 4 to get to x plus 9? Hopefully you see I'm not adding an x at all. My x's are staying just x, but I am adding a positive 5 to get from -1 to 4 and from 4 to 9. So my common difference here is 5. Now, I apologize, but I need to go back because I actually didn't answer the second part of the question. The second part of the question here said, and state the next term. So, what would the next term be in this first example? Well, I left off on 23, and if I wanted to find the next term, I would take 23 and add 6, which would be 29. So my common difference was 6, and my next term is 29. Okay, let's look at the next one. So -4 was my common difference. Okay, what would my next term be? Well, again, follow the pattern. Continue to add a -4 to the last term. So 4 plus -4 would be, of course, 0 would be the next term. Lastly, okay, we ended up with x plus 9. I have a common difference here of 5, and that means I'm going to add 5 onto x plus 9. So x plus 9 plus 5 would be x plus 14 would be the next term. Okay, the next example is giving us a sequence, 100, 97, 94, 91, and on and on and on. And it's asking us to do 3 things. First, find the common difference. Second, write an explicit rule for the sequence. And third, find a specific term, the 20th term. All right. So let's start with the first one. We've already talked about finding a common difference. You're just going to say, what do I add to the first to get to the second? That same value to get to the third and the fourth, and so on. And hopefully you can look and recognize you are in fact adding a -3. So my common difference, my D, is -3. The next one asks you to write an explicit rule. Now, if you recognize that you are adding or subtracting a common amount every time, to one number to get to the next, then you know that this is arithmetic. So we need to grab the formula for arithmetic sequence from our formula sheet. Okay, so you can see that's written right up on the top of your page. It's a sub n equals a sub 1 plus n minus 1 d. So we write that out. Now remember what it said in that box. It said we always need to be able to fill in a sub 1 and d. Those are the 2 values I need to know. So, looking at this, a sub 1, of course, is our first term. Remember, that's your first term. And my first term here is 100. Okay? D, we just found to be -3. That's your common difference. Now, those are the only 2 values you're plugging in. Notice that your explicit rule has to be in terms of n. So you are leaving n as n. And you might want to write yourself a note. Okay? Leave n in the formula. Do not plug anything in for n. So what you're going to do is replace, so it's a sub n equals, a sub 1 we said was 100, plus n minus 1, leave n, times d, which is -3. Okay, notice I put the -3 in parentheses because I don't want it to look like -3 there. It's times -3. Okay, the last question here asks for the 20th term. Well, now they're giving you the n. See, the 20th term is telling you n equals 20. Remember, a sub n is saying n is your nth term. So if they're asking you for a specific term, now we're ready to take our formula here that we just wrote in part B and replace the n with the 20. So 100 plus 20 minus 1 times -3. And so you can type that in your calculator, and you will get a response of 43. Oops, 43. Okay, so the 20th term in this sequence is 43. All right, last one we're going to do tonight. It says Cooper is saving to buy a guitar. In the first week, he put aside $42 that he received for his birthday. And in each of the following weeks, he added $8 to his savings. Write a function, S of W, to represent this sequence where S represents Cooper's total savings and W represents the number of weeks he has saved. Okay, as we look at this, last year you spent a lot of time learning how in 8th grade to write linear functions. And there's not much that distinguishes this from your traditional normal linear function. Okay, many of us are going to be tempted to think of $42 as your starting amount. And in some ways it is. It's the first amount he saved. But this right here, the fact that they told us this was the first week, that's different than saying he began with $42 in the bank and then added $8 every week. This is saying in the first week, when you realize that they are giving you that clue that we are starting with the first something, that's how you know you have to use an arithmetic sequence. And guys, there have been problems on the exam where they have not said write an arithmetic sequence to represent this. And so you have to know, as a student, you have to be very careful to read and recognize when you see that it says first, that that is telling you it's arithmetic. So because of that clue, first week, we know that this is an arithmetic sequence and we need to write down our formula from our formula sheet. Okay, now what are the two things that I need to plug in for this? I need to know A sub 1 and I need to know D. A sub 1 is our first amount. So in this case, our first amount that he has put aside is 42. And then every week, he's adding $8. Your common difference is the amount you add every term. Well, it sounds to me like your common difference here is $8. Now I'm plugging that in. A sub n, and remember I leave it in terms of n, equals 42 plus n minus 1 times 8. And you can leave that formula like that. If this is multiple choice, it is likely that they might actually expand that out. And so think about this. You have a binomial times 8. This is just like distributing that. So A sub n equals 42 plus 8n minus 8, which when I combine like terms gives me a final answer of 34 plus 8n. And so I just want to point out, you can see that this is different than if you had just jumped in and tried to write a linear equation. If you had just jumped in and written a linear equation, most of us would have written 42 plus 8x, right? 42 was your starting value, and 8 was your rate of change. Well, obviously, looking at my answer here, that is not what I should have had. And that's because 42 was not my starting value, 42 was my first week value. Okay, so it's a little different, and you just got to, really pay attention to that. Okay, before we conclude, I just want to give you 3 questions here that will be excellent review for your quiz coming up. So if you want to pause the video and write these 3 questions down, just on a separate piece of paper, or you can put them on the next page in your notebook if you want, and you're going to go ahead and just answer these 3 questions. Do the best job you can. We're going to be checking for that, and then we'll go over them before your quiz. But it's a great way for you to review. I promise questions like this will be very similar questions will be on your quiz, and so it will definitely be to your advantage to take the time and answer these 3 questions. All right, so thanks a lot, and hope you have a great night. We'll see you in class.